Hi everyone, this is what is this? The second, the MP3s and DVDs lesson. And this is actually from yesterday's lesson or the other time's lesson, the last lesson that we did. We didn't get to some of these problems, so I thought it would be great to practice them as I do now. And for those guys who like to have like steps on how to solve these kinds of problems, again, this is just a generic like list. It's not like, oh, you have to do it in this way, but this is generally how you do it. And again, it depends on each equation, like what it looks like. But generally, this is what you're doing. It's the general concept of it. Okay. So first thing is, if you look at number one, is just get the x on one side. If you have x's on both sides, get them on one side. Okay, by either adding them or subtracting them, depending on whether they're positive or negative. All right. And once you've done that, then you want to get rid of all the pluses and minuses that are on that side. Usually that comes first, unless you have parentheses going on there, right? And then you're going to get rid of the whatever's in front of the x, right, or below the x. It's either like multiplying or dividing, right? So that's what you're going to do. So it's basically the reverse of order of operations you're thinking in your brain, okay? And if you notice my step 0 here, so if there are fractions and you don't want to deal with them, then you're going to multiply both sides by the LCD, which is the least common denominator. Okay, so meaning whatever number is on the bottom of the fraction, that's what we're going to multiply it by. If you have two numbers that are in the denominator, then you find the number that goes, that both of these numbers go into. Okay, we'll have that's like number 3. We'll do that in number 3. And then you're going to get rid of parentheses and all that kind of stuff. Okay, so, and again, the only way you're going to get better at these is if you actually do them. So if you did not do them in class, or if you were not in class, I would just write this, the problem number 1 down. So 12.6 plus 4x is equal to 9.6 plus 8x. So you're going to copy that down, and then you're going to just do it. And if you really don't know how to do it, then, just follow along with me and we can do it together, right? Just make sure you're doing it as well. You're not just looking, because looking is different than you actually doing it. Okay, and then for number 2, number 3, try doing them by yourself as much as you can. All right, that's what I would suggest. And please pause me at any given time. Okay, don't let me just keep on going and then, that's not good. I don't care, because this is a recording, right? So anyways, so here we go. So the first thing we're going to do here is I'm going to get the x's on one side. I did try to color coordinate these. So no, these are color coordinated. So this step is this green step right here to see something. All right, so we decided we were going to get the x's to the right. So because if we subtract 4x on both sides, that keeps the x positive. And I like doing that just because, I don't like dealing with negatives. So we're going to go 8x minus 4x, which is 4x here. Everything else that we did not use gets copied down. And if you notice the 4x minus 4x, where did it go? No, it just became 0. And we don't normally write zeros down, because what's 12.6 plus 0? 12.6, right? So there we go. That's what we call canceling out. And then it says eliminate the plus or minuses. So here we have the furthest thing away from the x is this 9.6. So if you notice, how do you know if you add or subtract? Well, look if is it positive or negative, right? And so, because if I say, oh, it's a plus 9.6. So think about it. 9.6 plus 9.6. Does that cancel out to 0? No, it's like 19.2. Not what we want. I mean, we can, it's just not helpful for us. And it definitely doesn't become 0. So that's what we know we're going to subtract it. So 9.6 minus 9.6, what is that? 0. So that's going to be 0. So that cancels out. And then we're doing, again, same thing on both sides, subtraction property of equality. So 12.6 minus 9.6, which is just 3. Okay, so, and then we did not use the 4x, so we got to bring that down. So 3 is equal to 4x. See how it's much simpler now? And then now we're getting really close. We're almost to what x is equal to. So notice that we got this 4, which is multiplying. That's the step right here. So how do we get rid of a multiplying by 4? Or how do we undo that? We divide. Undo multiply with division, and undo division with multiplication, right? You don't, yeah, anyways. So it's going to be divide by 4 on both sides. right? And then so multiply by 3/4. So, sorry, x is 3/4 is what I meant to say. So if we plug this 3/4 back into this equation, it's the only number that's going to make it work. Any other number, even if it was like 3/5, it's going to make it wrong. Okay, it's not going to work out for you. All right. So again, try number 2. Try to do it by yourself. If not, try not to look at the ones below, like cover it up. Like, I can't do that. I could cover it up, but then you can't see my hand. No use. So do the exact same thing and check your work, see what you did, but your answer should be -10. And you might want to try, well, instead of moving the x to the left, why not move the x to the right? Because technically, if you move it to the right, we won't have to deal with negatives. I'm just saying, not until the very end. But it will, your number will eventually be -10, but just for the most part, you won't have to deal with negatives until the end part. I'm just saying. All right, so that's, you can try that, but either way, you should still get -10. All right, so for number 4, this one I wanted to go over just to make sure in the video, because it has to do with our fraction business, right? So if you notice here, we have 2 and 4 on in the denominator. So we have to, okay, we have to think to ourselves, since we have 2 different numbers, we have to find another number that both 2 and 4 go into. And you'd be like, okay, well, always what I would like to try is 4. I try the biggest number first, right? Does 2 go into 4? Because I know 4 goes into 4, but does 2 go into 4? And we're like, yeah, it's even. So that totally works. So my number that I'm going to multiply is 4. Okay, so I'm going to multiply 4 with everything. So that's why I put the parentheses around the whole equation. Okay, some teachers, they may do like 1 for each side, and you can do that, right? But it just gets it just gets messy for me. I just like to do it for the whole thing. All right, so this is what we're going to do. So if you notice right here, that is, we have a big divide. So this is technically just one thing, one entity, right? So what I'm going to do is I'm just going to go, well, what's 4 divided by 2? Well, 4 divided by 2 is just 2. So notice that goes right here. So I'm going to maybe highlight that. Maybe the highlighting will work. So the 4 divided by this 2 is this 2 right here. You see what I'm saying? And notice that we're still need to multiply this 2 with the whole top part, 10x plus 2, because we didn't technically do that part yet. So we're just gonna do that later. And then we're gonna multiply the 4 times the 4, this 4x right here, which we would get 16x, and the 4 times the 1/4, which is 1. So some people may ask how we got that. So one way to, this is not how I do it. This is how some people like to do it. And I'll show you the other way that I like to do it. So they're like 4 times 1/4 is like, so if you multiply the top, it's 4 times 4 times 1, which is 4, divided by 4. What's 4 divided by 4? 1. But the way I like to do it, just because it's a little bit shorter, is, well, I know this is like over 1, right? In my brain, I'm doing like over 1. And then I go, I know 4, I can cancel out the 4s because 1's on top, 1's on the bottom, because 4 divided by 4 is what? 1. So then what do I have left? 1 over 1, which is just what? 1. Do you see how I can skip this whole step here? I could just move on quickly to the next to see what it's equal to, right? So either way you think about it, it's fine. Okay, so just use the one that works for you, right? I like to cancel things out to, as many times as I can, right? And so for me, I'll cancel the 4s out and be like, oh, all I have left is the 1. Definitely not 0, because 4 divided by 4 is not 0, it's 1. And then whatever this number is, that's what we're multiplying by. This happens to be 1, so it's 1 times 1, which is 1. All right. So moving on. Now we've done all that fraction stuff. Now we're gonna just head into step 1 right here, which is get the x on one side. And so I noticed that my bigger x is on the left, so I'm gonna just subtract 16x on both sides, right? Remember, this is positive, so that's why I'm subtracting it, because 16x minus 16x is 0. So this cancels out. And then all we have left is 20x minus 16, which is 16x, which is 4x plus 4 is equal to 1. So far, so good. And then now we're going to eliminate the pluses and minuses, the thing that's furthest away from the x, which is the plus and minus. So since it's add 4, we're going to subtract 4. And then here, since it's multiply by 4, we're going to divide by 4. This is a separate thing. So when you write down 4x, don't go, oh, 4x divided by 4. That's not the same step. So once you have 4x is equal to -3, right? This is the equation. How do we get rid of that 4? Divide by 4. Do you see how we do it as a separate step? A lot of people do that wrong. I think they think that this is the same step. This is not the same step, right? So we divide by 4 afterwards once we get the previous answer in there. And then we write x is equal to what? -3/4. Okay, that's what we would do. Let me just erase that. All right, so that was the do now. I know it was a little bit long. And there are some more problems in here, so you can totally try them if that, I don't know, I kind of want to try them too, but that is not for this video. We are going to go to the next page here, which is over here on the right, because it got overlapped. So if you look right here, it says one solution, no solution, and infinite solutions. This is actually possible. We'll take a look at this. So if you look at here, Amy and Damon were solving an equation with their math from their math homework, right? And this is the equation that they got, right? And they both did them in different ways. And if you want to also participate in that, you can just do this over here on the left, right? I would just copy this down. 3x plus 7 is equal to 5x plus 2 times 3 minus x plus 1. And I would do that instead. You know, I think that sometimes is more helpful, right? But if you take a look at what, I like Damon's approach better just because it's a little more succinct. I'm doing like, I'm trying to simplify things a little bit better. So if you notice first, what Damon does is distribute, right? So that's what we're going to do. We're going to get rid of this parentheses, okay? So what I'm going to do is, so I'm going to copy everything else down except for this part right here. So this is going to be, I'm going to actually distribute it. Let's do this purple color. So 2 times a 3 is going to be plus 6. And then 2 times a negative x is going to be minus 2x. Okay. And then we're going to plus here, plus 1 right there. All right, because we didn't use that yet. So notice we have no more parentheses. We got rid of it because we distributed that 2. When we distribute that 2, that means we're multiplying the 2 with everything inside the parentheses. Okay. So now, if you notice on the right-hand side, it says pretty long. I can combine some like terms here. I don't know if you knew that, but if they're on the same side, right, they're all on the right-hand side, we can just simplify them by combining like terms. Okay, so that's what we're going to do. We're going to combine like terms. So again, so 3x plus 7, I'm just bringing those down because we haven't used them yet. And then on the right, well, I have my 5x here and my minus 2x. What's 5x minus 2x? 3x. If you have 5 x's and you take 2 x's away, what do you got? 3 x's left, right? At your age, I hope you have no x's, but you know, that's just me. So here we have a plus 6 and a plus 1. So plus 6 plus 1 is plus 7. Just like that. Far okay? So do you see how we're doing this? We're doing this exactly the way, well, not exactly, because what Damon did was he switched them around. So he got all the x's, he gathered all the x's together and all the numbers together. Right? There's a property about that, right? Was it associative property? I have not taught that part in so long. And then from here, what we're going to do is if you notice something interesting. 3x plus 7 is equal to 3x plus 7. Is that always going to be true? Yeah, but we're going to continue. So remember what we said. What we like to do is we like to get the x's together. So we're going to get the x's together. We're going to just subtract 3. So we're deviating from Damon's what is it called, method here. And so when we subtract 3 x's, what do you guys notice? 3x minus 3x, 0, cancels out. So all you have left is 7 equals, well, you have this 3x minus 3x, and that cancels out. So all you have left is the 7 on the right. So literally you have nothing else left. There are no x's. It's just 7 is equal to 7. Is that true? Yeah, it's true. But what happened to my x's? So what can my x's be? And if you notice here, Damon, he did a little bit differently. He got the numbers together first, and then realized it's just x is equal to x, which means x. You can put anything in for x, and it doesn't matter because it's going to cancel out anyways, right? So x could be 10, x could be a million, x could be 4,262, x could be negative 0.2226, because it doesn't matter. It's gonna work out anyways, right? I wish I could show you that, but yeah, I would even just plug in a number in here, right? But remember, think about it. Whatever this x is, right, it's going to be the same number over here on this x, right? So if we multiply the same number by 3, then add 7, you're going to get the same result, right? Do you see how this makes sense? Hopefully it makes sense. Maybe it's just me. I don't know. But so yes, so this is how that works. So this one, the answer is infinitely many solutions. That's how I like to say it. I think the book says it, infinite number of solutions. Either way is okay. If you're conveying the fact that it's infinitely many or infinite number of solutions, that's fine. That means that x could be anything in layman's terms, right? Look that up in Urban Dictionary. Just kidding. Okay, so let me see here. I'm gonna go, oh, we'll do this one. Okay, so let's try this one. So we're gonna do this one ourselves as well. So 3, we didn't do this one in class, but that's the bonus for watching a video, you know, because we could go over this too, just in case. Because if you want to see it, I mean, you see Amy and Damon's work right here, right? And it looks like, if you guys take a look ahead, it looks not good. What do we do then, right? Okay, so let's do some more practice. Again, try this out by yourself, pause, right? And then try it yourself. And then unpause and see if you got the same answer that or maybe, you know, well, we'll see. So first thing I like to do, again, is distribute. So we're going to get rid of all the parentheses. We're going to distribute all that. So this is going to be 3x minus 15. If you wrote down 5, that's wrong, because you didn't distribute the 3 to the 5. And that's why it's inside the parentheses, so it could get the 3 as well. Right? We got to be fair. And then plus 11. We don't distribute to the 11 because guess what? It's not in the parentheses. It's outside of that, so it don't matter. So this is going to be x. And then we have 2 times x, which is 2x. 2 times 5, which is 10. Just like that. All right. And I notice I can simplify here. I can combine like terms. So that's what I'm going to do. So 3x is just 3x. Like there's no other x's on the left. So that just stays. And then I notice that the negative 15, some people like to do circles. So, oh, maybe that's a little weird. I don't know, but I like to underline. So the negative 15 plus 11, that's going to be minus 4, right? And then we're going to go equals. And I notice here that let's make them orange. I have my x and my plus 2x. My x's I have as common like terms is what I'm trying to say. And oh, okay. So that should not be that. So x plus 2x is 3x. And then my 10 is, I don't have anything to add it with. Can't add it with the minus 4 over here because they're on opposite sides of the equal sign. Can't just cross over like that. It's not cool. All right. And then from here, what are we going to do? What we like to do is, remember, we get the x's together, right? If you don't like getting the x's together because they fight all the time, I'm just kidding, then get the numbers together. But I like getting the x's together so that I know exactly where I need to go, because the x is only on one side and it's not like confusing, because I think that confuses a lot of people. So then from here, the only times you should get your x's together, right? Minus 3x. As I said in class, he knew it was all about relationships. All right, we're subtracting 3x on both sides. And there we go. So they're both, what? Cancel out? Yeah, they both cancel out. And so all we have left is this negative 4 is equal to 10. Well, okay, from my past experience, negative 4 has never equaled 10. They're not the same things. Like if I had $10 in my bank account is not the same thing as having -$4 in my bank account, right? Because one of them would incur like an NSF, like non-sufficient fund charge. Don't want that, because that makes you more NSF. And $10 is fine. So here, this is definitely not equal. So we're just going to include it, just that little slash right there. It is usually going from right to left. For you guys, it'll be like this way, right? From right to left, and that is not equal. When this happens, what does that mean? So is it, so if you take a look, let's analyze this a little bit further. So if we take 3x and we subtract it by 4, is that going to be the same as taking the same 3x and adding 10 to it? Will they ever be equal to each other? Not on any planet, right? It doesn't make sense. So this is an impossible equation. So if your parents ever tell you, if you find the x for this, then I will give you $1,000. You know that that's bad. They won't tell it to my kids. No, because there is no solution. There's literally no solution. So you would just be like, no solution. There is no x that will work for this equation. Nothing, 0. It is not possible. That's my solution. So whenever this happens, you know that's no solution. Okay, dokes. But for most things, for like when we're doing these kinds of problems here, how many solutions do we have? Just one. It's one solution. That's what we want. Okay, these are the ones that we typically have, right? But then there are special cases where the x's completely cancel out, and when we get like things like 7 is equal to 7, which is true, 7 is equal to 7, right? Then that's when we have infinitely many solutions. And when they are the other way, that would be, oh yeah, that's no solution. So as a wrap up, okay, you might want to write this in your book, not in your book, in your notebook or something like that. Not this whole sentence, but I would write down infinite number of solutions, or infinitely many solutions, whatever way you want to say it. So how do we know if it's that? So basically all the x's cancel out, right? And I should say that the number, whatever number is resulting, is equal to the number. This is true, right? That has to be true. Or you get something like x is equal to x, right? Like how Damon did, in which case, oh, this is infinitely many solutions. So I'm going to just keep on saying it that way because I'm so used to it. So the only time you would say no solution is, again, if all the x's cancel out, but in this case, this number, so the two numbers that we have don't equal each other. That's a false statement, right? That's when we would say, oh, no solution. And so the one solution, you don't have to state that it's one solution. You just state what the solution is, which is x equals to whatever the number is. Okay. And then what I did ask was, well, what if we get x equal to 0? That's still a solution. X is equal to 0. It's a number, right? So this is definitely, so some people get here and be like, oh, no solution. It's a solution. The solution is 0. That's the solution, right? So this is definitely a solution of one solution, just so that you know, it's not confusing. So we did some practice here. So if you notice, yeah, just take a look. I would practice it. I'm going to do number 1. Okay. I'm going to do number 3. I'm going to, let's go down. Should we go complicated? We'll do we did one that's similar to this one. So number 8, but so we'll do number 9, that kind of like, oh, that's kind of weird. This is kind of like the challenge problem, right? So we'll do number 9. And then, so what I'm going to do, let's do number 5. Okay. Just to make it interesting. All right. So I'm not going to do all of them, but if you do one of the problems and you're like, I need some help on that, or you're like confused and you want to know the answer, just let me know. Okay. And then I will show me the work and I'll help you with that. All right. So let's take a look at number 1. Please press pause. Do it yourself. All right. So here we go. What I'm going to do first is I'm going to, okay. You ready? Remember before I said okay, when we have a fraction, we have to multiply by the denominator. There's only one denominator, it's just 4. So the number that we're multiplying is pretty easy, it's just 4, right? So I'm going to just go like this and be like 4. Okay, so now this is the part where it could get a little confusing, but you're fine. You're cool. Okay, you ready? You got your eyes peeled open? Now it's weird. If you notice, right, remember the 3/4 is multiplying already with this thing. So that is one entity. It is one thing. Okay, so we're not like distributing right now or anything. Okay, so we're just taking the 4 and you're multiplying with this whole thing here, this whole thing. This is the whole shebang. Okay, so 4 divided by 4 is what? 1, right? So all we have left is a 3. So all we have left is 3 times 2x plus 5. Okay, that's what we have. So now we've dealt with that part. So far, so good? I know it's weird because you want to just like multiply with the 2 as well. You can't do that because remember they're multiplying, right? And then so equals 4 times 14, which is 56. All right, just like that. So far, so good. Now what we're going to do is like what we've done before. Now that we have no more fractions, happy days. Now we're just going to distribute like we normally would. All right, so we're going to distribute this guy. So 3 times 2x is 6x. 3 times 5 is 15 equals, 56. I'm just going to keep it all one color. All right, and then from here again, remember the next step was to get rid of the plus and minus, right? Because we have no more parentheses. Everything looks normal. This is like a 2-step equation. So this is going to be just subtract 15 on both sides, right? And how do we know that? Because 15 minus 15 is 0, right? That's how we know that. And so what we would get is 6x is equal to 56 minus 15, which is 41. All right, and then we're almost there. Well, what would x have to be? Well, remember we're taking that 6, since it's multiplying, we're going to just divide both sides by 6. And so what we're going to have is x is equal to 41 over 6. Okay. All right, so your answer is going to be x equal to 41 over 6. So if you're one of those people who are like, oh, I'm just going to try and guess the number. Yeah, I don't know how you're going to guess 41 over 6. So please make sure you learn this way. This is going to help you really, really, really in the long run. Because again, most answers are not whole numbers, right? In life, answers are not whole numbers. I wish they were. Life would be a lot more simple, but it's not. All right, so let's take a look at number 3. Number 3 is the unique one, all right, that I said, you know, like you're going to have to practice more of these. Okay, so if you take a look at this, notice the big fraction, right? So we got to get rid of that first. So how do we get rid of that big fraction there? Got to get rid of that 3, right? We're going to multiply by, oh, look, it's already there. That's the problem number 3. And so I'm going to just write down 3 there. So we're multiplying everything by 3. So remember the everything on the left-hand side, this is all multiplying. So this is that's one big fraction. So that's the everything on the left-hand side. So 3 and this 3 here cancel out. So all we have left is whatever's on top. So I'm just going to just copy that down. Just like that. Is equal to 3 times 7, which is going to be 21. Okay, so we multiplied 3 on both sides. Multiplication property of equality, right? Now we have no more fractions, happy days. And now we're going to distribute. So let us distribute. So we're going to go 21 times, I already did it in my head, -7 times 3x, which is going to be -21x. Oh my goodness, I can't write. 21x, and then -7 times 6, which is going to be -42. And you'll notice that I just said -42 instead of -42. I really interchange negative and minuses a lot. Like if you have the iPhone, I think it was iPhone, where if you want to put negative, you just push minus. Is that not the iPhone? Well, it's Desmos for sure. So it was one of them. I don't remember, but yeah, it's the same. It looks the same. It is the same. They're interchangeable. I'm gonna just interchange them. Just saying. Okay, so then from there, I'm going to get rid of this minus 42 because remember it's subtracting. So what's the opposite of subtracting 42? And so if you're like, oh, I just subtract 42 on both sides. And then you can tell what's negative 42 minus 42. It's not 0, it's negative 84, right? Check it on your calculator, right? So make sure you put plus. That's how you can check. So negative 42 plus 42. If you think about it, you're like, oh yeah, that does cancel out, right? And then what do we have left? So it's going to be negative 21x because, you know, we didn't touch that yet. That cancels out. And this is going to be equal to 21 plus 42, which is going to be 63. And then what do we have? So we're close. So this is multiplying. So negative 21 times x. So that's why we would divide by negative 21, whatever that number is. And then we get our answer of 63 divided by 21 is 3. So this is going to be negative 3 because one of those is negative. Just like that. Okay. That's negative 3. So if we were to plug this back in, it would work out. So let's try. I said we would go to number 5. So we're going to try number 5. So hopefully you're doing this along with me, right? You're doing it by yourself, trying it out. All right, first step. Oh, good, no fractions. So nothing to multiply by, right? So we're done with that part and we're just going to go straight to, oops, changing the colors. I'm going to just distribute that guy. So negative 50x plus 100, because remember negative 50 times a negative 2 is going to be positive 100. See what I did there? All right, so then from here, I'm going to get the x's together. And here I would highly recommend that if you only have the x on one side, bring the other x to the other side. Okay, because if you don't, well, I'll show you what happens. And you can do it. It's not wrong. It's just long. Okay, so here we go. So we're just going to add 50 to both sides, or 50x, I should say, plus 50x. And then we get 90x is equal to 100. And then how to get rid of the 90? Got to divide, right? Divide by 90. And then so we're going to have the answer of x is equal to 100 divided by 90. And I know that zeros can cancel 10 over 9. So remember, it's going to be 100 over 90. Just remember that we always simplify. So it's going to be 10 over 9. You can leave it as 10 over 9. Don't do mixed fractions, okay? Unless we're trying to graph a thing, just leave it as 10 over 9. That's fine. Improper fractions are great as long as they're simplified. So remember, I told you I would say, so this is in the alternate universe. We'll use an alternate color here, alternate universe. So we have 40x is equal to negative 50x plus 100. So what would happen if we subtracted 40x instead, right? Because I told you it'll give you the same answer. It's just an extra step. So what do we have left? So this is going to cancel out. All we have left is what? 0. This time we have to write the 0 because literally there's no other number there. So we have to write 0. And then this would be negative 90x plus 100. All right, so now what? Well, let's take out the plus or minus, right? And then so this is going to be minus 100, minus 100. And this is going to be 100, 0 minus 100 is negative 100. We have negative 90x. And I'm like, see, it's different, got negatives. No worries, guys. All right, so then how do we get rid of the negative 90? Do not say add 90. You said add 90, go like this. I'm just kidding. I'm just kidding. So negative 90, remember they're multiplying, right? Because there's no operation there. So that's going to be divide by 90 on both sides. Or I'm sorry, negative 90. And then our answer is going to be, remember negative divided by negative? It cancels out, so it's just going to be 100 over 90, which we know is just 10 over 90, or 10 over 9. Oops, 10 over 9. Right, and notice same answer, right? Do you see? But do you see how it's like a bit longer? Right, I wrote a little bit bigger too, but it is longer. It's like an extra step that we don't need to do. That is unnecessary. That's why I like to, if you have an X only on one side, oh, like there's only an X on that side, then bring the other X to that side. It just makes life a little easier. I'm just saying. All right, this is why I'm saying you need to expose yourself to a lot of different kinds of problems, right? And then I said I would go over number 9. So, ooh, number 9. This will be interesting. I didn't get number 1. Okay, good. So number 9 is going to be fun. I can tell already. Shall we get rid of the parentheses? I mean, the fractions. Let's get rid of the fractions. All right, so here we go. So what am I multiplying everything by? The only thing in the denominator that I see is a 4. So I'm going to put, I like putting the 4 on the left, but you could put the 4 on the right. It doesn't matter. We're multiplying everything by 4. If you notice right here, this is just one big fraction bar. So this is just one thing right there, right? So this is actually going to be 4 divided by 4, which is just 1. So all we're left is with the top part right there. So -3 times -2x minus 5. All right, so -4 times this. Remember, this is also another entity, including that negative right there, right? So we're just multiplying it. It's literally, what color should I do? So it's literally going to be this 4. What we're doing is 4 times -5, 3x plus 5. This is what we're doing, right? And so are we multiplying the 4 with the -5 and the 3? And no, we're not doing that. So it's just going to be -4 times, or 4 times -5, which is just going to be -20. And we have not distributed yet, so we're going to do that now. Okay. Well, soon. We're going to distribute it soon. And then we have the last bit right there, which is going to be 4 times 5/4. Remember, those 4s are going to cancel out, so all we have left is just the 5. So plus 5. So kind of to color coordinate here, this is this part right here. Then we have the whatever color that is. And then we have the plus 5. Okay, so that's where they're represented. Now, what are we going to do? Now we're going to simplify things. So we're going to get rid of all these parentheses. So we're going to distribute to no end. So -3 times -2x is going to be 6x. -3 times -5 is plus 15 is equal to -20 times 3 is -60x. -20 times 5 is -100. And then we have that plus 5. Okay. And then we're just gonna, we have the left-hand side, we can't combine like terms because there's no like terms to combine. But on the right-hand side, I noticed that there are some things to combine, just the 100 and the 5, right? So I'm just gonna rewrite this. So 6x plus 15 is equal to -60x. And these guys are gonna be, is -100 plus 5. So that's gonna be -95. Now, remember what I said, we're going to get the x's together. So I noticed that I could either subtract 6x on both sides, but then that I deal with negatives, right? So I'm going to, instead, I'm going to just add 60x on both sides so that everything's positive, at least for the x's. Got to keep things positive with the x's. It's not stopping. All right, so then here 6x plus 60x is going to be 66x, right? Plus 15 is equal to, okay, remember cancels out, so -95. All right. Now we're almost there. Now it's this two-step equation. Everything boils down to a two-step equation, like literally, like seriously, almost all the time. So what do we do from here? Again, subtract 15 on both sides. We can't avoid these negatives at this point, right? Because, I mean, if you want to bring the 95 over here, you can, but then we're just going to bring it right back. You know, that's not great. So here's 66x is equal to -95 minus 15. So we're getting more negative. So it's going to be negative, it's 10, that's 20, so 120. Oh, -120. And then we're just going to divide both sides by 66, and we get x is equal to -120 over 66. Remember what I said, simplify if you can. So I know, I know 2 goes in there for sure. Okay, so I'm going to be like, okay, if 2 goes in there, so that's going to be negative 60, and that's going to be 33. I'm like, oh, maybe I should pick 6, huh? Well, c'est la vie. So I know 3 goes into both of them, right? Because, 3 goes into negative 60 20 times, negative 20 times, I should say. 3 goes into 33 11 times. Okay, 11 is a prime number, and that, yeah, doesn't go in. So this is going to be my number right there, right? So if you have any other questions, please make sure you try the exit ticket. See, check your understanding, see if you get it or not. Remember what we talked about. Come on, about all these guys right here, right? See if that happens. And if it doesn't happen often, but when it does, you know what to do, right? So I'll see you later. Bye-bye.